Hi, everybody. Welcome to today's session on planning split applications of nitrogen in protected soil-based systems. My name is Talia Plaskett, and I am the Protected Crop Specialist at Perennia. So today we're going to be building on our foundation for managing nitrogen in protected spaces and more broadly soil health and resiliency in these setups. For those of you who were unable to tune into our previous webinars with Judson, I highly recommend you check those out on our greenhouse production playlist hosted on the Perennia YouTube channel. So there you're going to find the part one for this series, where basically we outline some of the issues that we run into when we manage exclusively for nitrogen in these protected spaces, and sort of the challenges associated with that restricted precipitation that runs through there. The other webinar, we hosted this towards the end of March, and this is talking about the use of cover crops in protected spaces. Managing soil health is a complex topic, and the use of cover cropping alongside good nutrient management are going to play into one another when it comes to creating and maintaining those healthy and productive soils in our tunnels. So I definitely recommend sort of checking out both just to make sure you kind of have that full picture for your protected spaces. So today's webinar, we're going to focus on setting ourselves up for successful split applications of nitrogen. This session is brought to you in part by the On-Farm Climate Action Fund, which Perennia is administering to Nova Scotia and Newfoundland and Labrador on behalf of Agriculture and Agri-Food Canada. So our guest today is no stranger to the world of soil-based tunnel production. Judson Reid is the Senior Extension Associate at Cornell University with both undergraduate and graduate degrees in agriculture from Cornell. He manages a series of research and education projects for greenhouse, high tunnel, and field production of fresh market vegetables, and is involved in work surrounding grafting on tomatoes, biological pest control, cover cropping techniques, and soil nutrient management in protected agriculture. So without further delay, we're going to jump into the good stuff. Take it away, Judson.
Great. Thank you, Talia. I'm going to begin sharing my screen. And I want to echo what Talia shared with us here about soil health is a very complex issue when we're growing inside. My volume's okay, Talia?
Yes, looks good.
That's good. Okay. And I would also encourage you to check out our previous sessions, and particularly the second one, where we spent some time looking at cover crops in protected settings and how those contribute to biological health, which ultimately improves our ability to manage nutrients. Today, as Talia mentioned, we are dealing with the On-Farm Climate Action Fund, or that's a part of the reason that we're here today, and looking at how can we improve our nutrient management in these settings to tackle climate change by adopting these, what we call BMPs, beneficial management practices, to store carbon and reduce greenhouse gases. And today is more of a deeper dive on the actual nutrient management itself. In other words, how are we managing the nitrogen inputs in particular in these settings? But please don't think that we're doing so to the exclusion of the other best management practices that might focus more on the biological aspect of soil health. So again, check out those other webinars. And again, thanks to Talia and Perennia for inviting me to participate in this. So first, let's do a quick level set, not to review what we have covered, but just so that we are operating on the same platform for our discussion today. Because what we're going to talk about is how to calculate our nutrient applications, again, with a focus on nitrogen, but bearing in mind our other nutrients. Before we begin to talk about how do we do that, I want to remind people that we use three major tests to guide our decision-making process in these nutrient applications. First and foremost is that soil test. That's really critical. When we take that soil test, we're going to pay particular attention to a number of nutrients: phosphorus, potassium, magnesium, and calcium, and then our micronutrients. And then beyond those nutrients, we also want to look within that soil test, in particular at our pH and or our organic matter. Organic matter in particular is going to influence some of our decision making. Talia and her colleagues at Perennia are able to assist you with that soil testing process. They're familiar with the soils in your province, and so I'd highly recommend you reach out to her to get that test done. The sooner the better. I like to take soil tests in the fall because that gives me time to make decisions about how I'm going to manage that soil, and particularly if I need to add amendments that take time to react with the soil biology. The fall test gives me that opportunity. Next best time is right now. Beyond that soil test, I'd also encourage you to do a water test. And that, again, that's a pre-season activity in my mind. Water is the highest input by volume that we make to our protected settings. So knowing what's going on there is extremely important, and I won't spend additional time there today. Aside from mentioning that the third test that we take is a foliar test, and of course that happens when we have foliage to sample, and we can do that throughout the season to check how good of a job have we done with our nutrient applications that we're going to discuss here today, and do we need to fine tune them in any way? Because again, we're dealing with a very dynamic, biologically based system that is influenced a lot by our weather, both the amount of sunlight we're receiving that varies year by year, as well as temperatures. So again, I encourage you to reach out to Talia and Perennia to get those three tests set up right away. With that soil test, I mentioned where we want to pay attention, what nutrients we're looking at, but I didn't mention the major nutrient that we're here to talk about today, and that is nitrogen. And that is because in our soil tests, we assume that nitrogen is a blank slate year to year. In other words, we're assuming there's 0 pounds of nitrogen available to us, or 0 amount of nitrogen available to us in that soil. That's not really true. There is always some background level of nitrogen, and particularly when we have high organic matter soils, that can be a lot of nitrogen. However, to do our math, to make our calculations, we're generally going to assume we're at 0. And just as a reminder, the reason we're doing that, and the reason that we're here today to discuss this, is that nitrogen is a very mobile nutrient. It always is moving in one direction or another. It could be moving down through our soil profile, and that's problematic if it's leaching into groundwater, for example. It's being applied at rates that are too high. That becomes a human health concern, an environmental concern. It also volatilizes and then becomes an undesirable gas in the air. So this is why we assume it's 0, is due to that mobility that is just inherent in nitrogen. Okay. Our discussion today, we are going to combine 2 practical fields of agricultural sciences, and those are hydroponics and field production techniques. So we're using greenhouse technology to drive yield and quality in our crops, whatever they are, fruits and vegetables. Plastic, steel, perhaps we're adding heat to the system. All of these things are extending our season and increasing probably the total yield that we're getting, and hopefully quality as well. But to achieve those higher levels of outputs, that demand we're putting on the crop with increased growing degree days or heat units, we do need higher nutrient levels. And this is where we can borrow from our hydroponic friends outstanding science that lets us know what are the desired levels of nutrient within the plant and what are the desired levels of nutrients in our irrigation water or fertility system. However, this is also where we part company with hydroponic production, in that we're a soil-based system, and our calculations have to account for the existing banks of nutrients in the soil. And that's why that soil test is so important. So whereas a hydroponic grower can always reset their total nutrient level in, say, a rock wool slab, we cannot do that because our soil, the mineral fraction, has a cation exchange capacity and the ability to hold on to nutrients over time. Beyond that bank of nutrients in the soil, we also have to look at our pH, temperature, organic matter, and the biology. When we are making our decisions on how to apply nitrogen in particular, there's a few other factors we have to consider. Are we growing in a verified organic approach? Are we using conventional materials? Are we using a combination of those? That's also probably going to influence our decision on using bulk materials versus soluble materials. And what I mean there are fertility inputs that can be injected through an irrigation system versus those that are large and bulky and have to be applied pre-plant. Price is always a factor in commercial agriculture. And since we're in a protected setting without any rain or snow coming through that soil, we also want to be very mindful of the level of salts in whatever we're adding. So again, we're combining hydroponic and field production techniques, bearing in mind that we're dealing with a mineral soil and hopefully a living soil. Before I go any further, I do need to give you a heads up. I'm going to be using imperial units. That was Talia's suggestion, and I think it was a good one just because, again, I'm from the States, and so this is the language I use on a day-to-day basis. If I try to do it in metric, and I have many times, I end up making a lot of mistakes. So I'll be talking about pounds per acre, ounces, gallons, square feet, and of course, acres. I created a quick comparison chart here with imperial units on the left and metric units on the right. Again, no value associated with any of these. It's just what I'm comfortable using, and I'm happy to do my best to calculate in metric, but I'll make less mistakes if I'm in imperial units. I'll probably still make a few mistakes in imperial units too. The next heads up I want to share with you is that in our discussion here today, I'm using tomatoes as the lens for our nutrient management discussion. Tomatoes aren't the only crop, but throughout North America, they are the most common crop in protected settings, and that's because of their tremendous value in response to the technology and yield, particularly that we get from tomatoes. I will talk a little bit about growing some winter greens as well. We can make adjustments for other vegetable crops or other fruit crops if people want, but this is the lens that we're viewing our nitrogen management through today. So when I talk about bulk amendments, we're going to be talking about composts or other nitrogen sources that need to be distributed here with some form of spreader, because we're dealing with larger amounts than a highly concentrated form of nitrogen. This can apply to both organic and conventional settings. The other important technology that I'm going to refer to throughout our discussion today is an injector. Here we have a very simple setup. This is a water-powered injector. The brand here is Chemalizer. This is set at 1:100. In other words, for every 1 part of water that comes out of this, or every 100 parts of water that come out of this hydrant into the injector, there's a siphon down here in this stock bucket that is going to inject 1 part. And so this is permanently set at 1:100. It's a fixed rate injector. That 1:100 ratio of fertilizer to water, then goes out into an irrigation line. I'm running my cursor along it here, which then goes into our crop. And you'll see there's multiple buckets set up here so that we can have different stock solutions. This is where I'm going to talk about our concentration of nitrogen in either pounds, ounces, or parts per million. When I say 1 to 100, that applies to any unit. It's parts per million, it's ounces, it's always going to be 1 to 100. This is powered by water. This is an essential part of your greenhouse setup. From our previous sessions, we've learned that too much of a good thing is not a good thing. This is an example of a soil-based greenhouse soil test that is brought to me once we're at a problem stage. And I'll point out here quickly that our phosphorus is extremely high. It's actually 30 times higher than I want it to be. My potassium, although it's rated as high here, is actually low relative to the next two nutrients, calcium and magnesium, which are also sky high. And the calcium in particular, and the magnesium too, for that matter, are an order of magnitude larger than I want them to be. How did I get here? We got here in pursuit of nitrogen. As growers pursue those high levels of nitrogen that we need, they tend to over apply these other nutrients, phosphorus, calcium, magnesium in particular, because they come prepackaged in our fertilizers. And that is true to both conventional and organic sources. My friend there with the spreader that was putting out a compost, even though that's a lower concentration of these nutrients compared to a soluble conventional fertilizer, the ratio is still imbalanced. And if that is my source of nitrogen fertility, I'm going to grossly over apply these other nutrients. And that's how I get into this situation. And it's a major problem because it impacts our yield. The other value I want to point out here is our soil pH is 7.5. That is very high. And our soluble salts are at 3.2. I would like to have that value below 2.0. I'd rather have it down in the ones. So that is also a level of concern that's going to burn back our roots. And organic matter is high, up around 20%. All of those values are going to present themselves as probably nutrient deficiencies in the crop. And so then the typical response from a farmer, which I understand, is to apply more nutrients. And this is where we end up with over applications of nitrogen, which we're trying to avoid, not just for environmental reasons, as important as those are, but those over applications of nitrogen also further decrease yield and are hurting your economic bottom line here. So how do we avoid this? We're going to avoid this by taking a more precise approach to our nutrient applications. So let's begin with our known sufficiency ranges. This is actually from OMAFRA, the Ontario Ministry of Agriculture and Food. They have outstanding resources on protected agriculture. I use them all the time. And so we have known sufficiency ranges for tomatoes. And you can see that those sufficiency ranges are going to vary slightly depending on the stage of our crop. So nitrogen in particular, we can see at our earlier stages, we want to be between 3 and 5% nitrogen in foliar mass on a percent basis. And over time, that decreases slightly as we move into our harvest. We can see our other values here as well. And knowing the relative values, our desired sufficiency ranges, we can begin to choose our different fertilizer products if we have a soil test. Again, most of our soil tests are going to reveal that we probably have enough phosphorus, calcium, and magnesium, as well as the other nutrients, with the exception of nitrogen and potassium on this chart. That's going to push us towards fertilizers that do not come with prepackaged phosphorus, calcium, magnesium, or micronutrients. We're probably going to focus on standalone sources of nitrogen and potassium for protected settings. That pH value is very important because it does affect the crop's ability to take up nitrogen. What I am showing you here is data that we collected throughout my state. Each blue dot represents a foliar sample from a protected setting of tomatoes. And you can see a green and a red line that represent my desired sufficiency range for nitrogen, and an adjusted dotted line that shows the trend of what happens as I move along this horizontal axis at the bottom of the screen from a low pH of 6.2 to a high pH of 7.8. In short, my crop is taking up less nitrogen the higher my soil pH is. And that's why it's important to manage our soil pH to be down in the low sixes, low to mid sixes, because that means I can use less nitrogen because my crop is more efficient at taking it up in a lower pH setting. Going back to the working knowledge we have from our friends in the hydroponic world, we're looking now at our desired parts per million in a rock wool slab of our major nutrients. And again, this is broken into multiple stages of development. So early on, we're starting with a nitrogen rate of around 200 parts per million. That is going to bump up during our flowering stage, or our vegetative stage, actually. And then it's going to back down to the 200 range during a harvest stage. Different sources will give you slightly different ppm rates for these different stages of the crop. I would tend to use a slightly lower rate than what we see here in a soil-based setting. And one of the reasons is our organic matter, as we discussed in previous webinars, has the ability to release nitrogen over time, particularly if our biology is active. Those soil microbes can mineralize nitrogen and make it available to our crop. So I would probably work with a target ppm, a target parts per million nitrogen, if I'm taking that approach, of in the 100 to 200 parts per million range. And again, I'm going to probably have an arc of starting out at a lower ppm, maybe 150 ppm, moving up into the 200 range, and then backing down again over time. Because we have to remember that our tomato crop and all vegetables, particularly fruiting vegetables, also have an arc of moving from a vegetative stage, a flowering stage, a fruiting stage, and then that harvest continues over time. As that harvest goes on, we're dealing with a more mature crop, which at this point has a larger foliar mass relative to the amount of fruit that we're harvesting or that it's maturing compared to earlier in the season. And so that larger crop has, or that more mature crop is in a more balanced position to be able to support the fruit that it has on there, and it has a lower nutrient demand. So that arc of crop growth is going to mirror our nitrogen management on a parts per million basis. Within this table, I would like to point out the K column. K, as a reminder, is potassium. And you'll see that when we're dealing with that heavy fruit load, in this chart, that is about twice the parts per million of potassium as nitrogen. In some tables, you will see that at 3 times the level of nitrogen. When we're calculating our parts per million of nitrogen, we want to bear in mind how is that affecting our soil from a salt standpoint. And so here we can see a chart that will roughly create, if you look between the nitrogen column and parts per million and the electrical conductivity column all the way to the right, you can see those relative values. And so some people will use electrical conductivity as a shortcut to get to parts per million of nitrogen, and that's fine. These charts are readily available online. Total dissolved solids is another measurement of salts. So that is a quick snapshot of our desired ppm of nitrogen and a quick nod to potassium in that process. However, we want to talk today about split applications of nitrogen, particularly for people that are using organic inputs. This moves us to a pounds per acre approach. This is in some ways simpler than a parts per million approach. I'm going to stop my share for a second. And it works quite well. In order to create a split application using a bulk amendment, we need to know what is our target budget for the entire year in pounds per acre. In other words, in mass per area, per unit of area. The goal I like to work with is somewhere between 150 pounds of nitrogen per acre to 200 pounds per acre per year. So somewhere between 150 and 200 pounds per acre per year. I want that to be delivered across, again, that arc of the crop maturity that I discussed. However, I don't want to apply that all at the same time. And that's the temptation when we're dealing with organic amendments, because they're less expensive than soluble inputs. They tend to be applied in high concentrations pre-plant. There's major problems with that. So one of our guiding practical principles here today is to not apply more than 50% of your nitrogen pre-plant. I would suggest going up to that level. So 50% in my units is going to get me to somewhere around 75 to 100 pounds of nitrogen on a per acre basis. So in order to calculate how much of that input I'm going to apply, I need to know a few things. First, I have to know what is the input I'm using. So for an organic input of nitrogen or a bulk nitrogen input, I'm talking about things such as feather meal, peanut meal, alfalfa meal. You could even use blood meal if you want to. It wouldn't be my first choice. I need to know what percent nitrogen is in that bulk amendment, or if I'm using compost. So really, I'm suggesting now a fourth test. I know I suggest a lot of tests, but it's really important to know what is the percentage of nitrogen in that bulk amendment. The truth is, you don't have to do that test unless you made the compost yourself. If you're purchasing one of these amendments, really, that manufacturer has the responsibility to provide you with that analysis. I'm going to use feather meal as an example. That's a popular nitrogen source among organic growers I work with. And again, I'm shooting for a target rate, pre-plant rate of application between 75 and 100 pounds of nitrogen. So in this case, I'm going to put in 75 That's my desired rate. Talia, this calculator is showing, hopefully.
Yes, looks good.
Great. And so that's my desired pre-plant rate, 75 pounds per acre. Now, feather meal, I happen to know, is 12% nitrogen. So now I want to divide my desired application rate of 75 pounds by the percentage of nitrogen in my input. I've got to move my zoom bar. Okay. So I'm going to divide 75 pounds by 12%, or converting that percent to a digit, that's 0.12. That means on a per acre basis, to reach my pre-plant goal, I need to apply 625 pounds of actual product. Okay, so 625 pounds of feather meal is going to give me 75 pounds of nitrogen. But you're probably not treating a whole acre. In all likelihood, you're treating something that's much smaller than an acre. So you need to be able to calculate what is your greenhouse area. I'm talking about the square footage, or you can use square meters, that's fine. Or what percent of a hectare, if you use those units, is your greenhouse. In my case, I'm going to say it is 1/10 of an acre. It's a 1/10 of an acre. A 1/10 of an acre would be about probably a 40 by 140 foot greenhouse, gives me about a 1/10 of an acre. So now I'm going to multiply this 625 pounds of feather meal times the actual acreage that I'm treating, which in this case is 0.1, or a 1/10 of an acre. And that gets me to 625 pounds of feather meal that I intend to apply to my 1/10 of an acre high tunnel or greenhouse. That's going to get me to that goal of 50% of my total nitrogen budget ahead of time. Okay, and we can spend more time on that later. And Talia, am I showing something that says nitrogen management strategy now?
Yes, sir.
Awesome. Okay. So I'm putting out that 50% nitrogen ahead of time. And I'm going to share with you a few case studies of where people didn't listen to our recommendations. And in this case, 100% of that feather meal is applied pre-plant. So that would be the full 150 to 200 pounds of nitrogen applied ahead of time. And that pushes, in this case, this blue bar, which represents our foliar samples over time. So the blue line represents a number of foliar samples over time. And you can see I'm above sufficiency. So I'm up close to 6% on my first sample date. Why is that a problem? It's a problem because we're favoring vegetative growth over flowers when we have that high nitrogen. And again, remember, I said nitrogen is very mobile. So we're also probably losing a lot of that nitrogen that we applied pre-plant, either down through the water table or out in through to the air. Then that nitrogen takes a nosedive over time, and we can see in the harvest season, I'm actually below my sufficiency ranges. And at this point, I'm dropping flowers, or I have low quality. And this is one of the reasons that we recommend that split application. So in this case, again, I have too high of a nitrogen rate, very high early in the season, above 6%. I come down to acceptable rates, or acceptable percentage, except during the harvest stage, which is represented by the green dots and red dots. Additional soluble applications made through the drip season also keep me high. Now, again, that's a problem during harvest, if my nitrogen is too high because I'm delaying maturity and I'm probably decreasing the total number of flowers that the crop is going to set because I'm sending a signal to the crop to keep on putting shoots out there, keep on putting in growth. So you're spending more time pruning, trellising, and less time harvesting because that's what you're asking the plant to do with all this excess nitrogen. I find that excess nitrogen early in the season, particularly in cold soils, leads to calcium deficiencies in the crop, which is what we can see here. This is called internal blossom end rot. Probably many of you are familiar with blossom end rot, which happens in the real warm season when there's a calcium deficiency or water deficiency in the crop. Here, I have introduced a blossom end rot or calcium deficiency in this fruit because I over-applied nitrogen. And I sent the signal to the plant to keep on building more shoots and divert calcium away from this tomato fruit. And I did that again with careless approach to nitrogen. That's what that looks like on the inside. No one wants to eat that tomato. So now this is an example of appropriate nitrogen management or more appropriate nitrogen management. And here, the grower applied some compost pre-plant, ideally, again, at that 50% or less total nitrogen budget on a pounds per acre basis. And then in season, foliar tests indicate that nitrogen is dropping and the farmer is applying now an appropriate rate during the fruiting stage of the crop, which is keeping us where we want to be. So that's where we want to begin. So our split applications for nitrogen, we're going to pre-incorporate our nitrogen up to 50% of our total budget, and there's a number of options that we can use there. In each case, we need to know the percentage of nitrogen in the amendment to make a calculation based on our total square feet or meters. Once we've done that, we take our foliar tests, and once we see that dropping of nitrogen, before we get to a deficiency level, we begin injecting soluble forms of nitrogen. And the good news is that today there are a lot of options out there for us, including organic ones of highly soluble materials. And so here you have a 14% soluble nitrogen in an organic form. And so at this point, we are definitely borrowing from the working knowledge of our hydroponic friends. Even though we're in a soil-based system, we take a parts per million approach here. For conventional growers, we have a number of soluble nitrogen sources. Urea in particular is a high value one at 4600 and is probably the lowest cost. The other one I'll highlight here because I like the ratio of the potassium to the nitrogen is potassium nitrate. Now, how do I approach those soluble in-season split applications using this injector? All of our calculations are going to be based on an injector. And the easiest way to do this math is to assume the injector is set at a 1:100 ratio. Some are fixed that way, some can be adjusted to be set that way. One of the major benefits of using a parts per million approach is that we know we're applying a dilution of nitrogen and other nutrients that is exactly what the plant needs based on its growth stage, regardless of plant size. We can also, using a parts per million approach, avoid high salt levels. Whereas if we use a pounds per acre approach, we can move very quickly into overloading the system. So there are formulas that will help you calculate your injection rate based on your desired parts per million and the known percentage of nitrogen in your fertilizer, whatever that is, conventional, organic, doesn't matter. And so this is an example of an online chart that would help you do that. The column all the way to the left shows you your percent nitrogen. What that means is the percent nitrogen in the bag or bottle or jug. So is it a 5% nitrogen? Is it a 20% nitrogen? And then moving left to right, this shows me three different actually parts per million, assuming that my injection rate is 100 parts or is a 100 to 1. So we discussed a high level of 200 parts per million as being kind of our peak demand on a ppm basis for tomatoes. So again, at this point, I'm talking mid-season, and I want to use this parts per million approach to be at 200. And let's say I've got a 14% nitrogen. That's what I just showed you. I'm going to need to apply, in this case, 19.3 ounces to achieve per gallon on a 1 to 100 basis to achieve that 200 parts per million. So again, there are formulas that will help you get here. I think most farmers prefer a chart. I'm not very good at math. I prefer a chart. You know what's even better than a chart is a calculator. And the good news is there are calculators that will help us do this as well. Okay. So Talia, now we're looking at the dosatron screen, hopefully.
Yeah.
And again, no endorsement here, but we do need to be to acknowledge the major brands that contribute to our success in agriculture. In this case, Dosatron, which is an injector company, offers this and many other calculators online. And I love this because I can put in here my desired parts per million, and we've discussed this. Those charts exist. Generally, we're somewhere between 150 to 200 parts per million. Let's use 150. So I put that into the first field. And now the percent of nitrogen. Well, what the calculator is asking you here is what's in the bag. Is it a 14% nitrogen? Is it a 20% nitrogen? Let's say it's 14, just because I showed you that example. And now the injection ratio. And again, this is, I like to have it fixed at 1 to 100. Again, I'm not great at math. So using one injection rate simplifies things for me. There are variable rate injectors out there. You're welcome to use them if you want to. I'm going to go with 1 to 100 here. And again, to simplify my math, I'm going to say I have a 1 gallon stock tank. That's a small stock tank, but putting the value, the unit of 1 here tells me how many ounces of fertilizer I have to use per gallon in my stock. Hit that calculator, and there it gives me the value I need. So that is ounces, and that's on a weight basis. 14 ounces in 1 gallon of stock in a 1 to 100 injector will get me to my 150 parts per million of desired nitrogen. Now I can use this approach throughout the season, coupled with foliar tests, to again keep that foliar percentage somewhere around, say, 4% nitrogen in the plant. And all I need to do is use this calculator or any other chart and know my injection rate and my percent nitrogen, or in the product I'm using. So thanks to Dosatron for that calculator. There are other ones out there. Now, there are limits to that parts per million approach. I'm going to share those real quickly. I think one of the greatest limits to a parts per million approach is that it doesn't account for where is that nitrogen going always. And this is the difference between a soil-based system and a hydroponic system, where either that water is being circulated or it's being entirely taken up by the crop. Where is our water going in a soil-based system? For a well-drained soil, we may have to irrigate for several hours a day to meet the water demand of the crop, not the nutrient demand of the crop, but the water demand of the crop. And if we are irrigating at a continual 150 parts per million N for several hours a day, and our soil profile is just creating a downward path for that water, that irrigation water, we're losing all of that nitrogen. The plant's taking up what it can, but we're wasting a tremendous amount of it. It can also be a challenge when we're dealing with a very large crop, or we're in the warm part of the year. And again, since we rely on passive ventilation, there could be a lot of wind inside of this greenhouse, which is again putting a lot of water stress on the crop. So in that case, we may want to go back to a pounds per acre approach. If we're using a pounds per acre approach in mid-season, we are going to be somewhere around 5 to 10 pounds of nitrogen per week to meet our need. So now going back to my calculator, let's clear everything out. If I know that my total nitrogen budget is somewhere around 150 to 200 pounds per acre per crop, and I'm taking a conventional approach of having not applied any nitrogen ahead of time, I'm going to be applying probably between 5 to 10 pounds of nitrogen on a weekly basis to achieve that total nitrogen budget of 150 to 200 pounds per acre. I would like to see that application of 5 to 10 pounds per acre per week divided into a minimum of 3 applications per week, probably better 4 applications per week. So what I'm suggesting is that we take a target value of 10 pounds per acre per week. And again, I need to divide that target of 10 pounds by my actual nitrogen. So let's again use 14 because I shared that product to get my actual amount of product needed out there. So dividing 10 pounds of target N by 0.14, my percentage of nitrogen in the product, means that I would need to apply, yikes, 71 pounds on a per acre basis. Now that's the good news. I'm not treating an acre. I'm going to treat a tenth of an acre, which means I'm going to multiply that value times my acreage or square feet or square meters, which in this case, we're going to say is a tenth, which is 0.01. That means I'm going to be using about 7 pounds of that 14% nitrogen product on a weekly basis. Now, to further break that down so that I'm not shocking the plant with too much nitrogen at once, and I'm not losing nitrogen to the environment either up or down, I want to divide that between, let's say, 3 applications per week. Now I'm going to be applying about 2.4 pounds of product 3 times a week in however much water I need sufficient to irrigate the crop. On the days where I'm not applying this, I'm going to be running clear water just to keep my salt levels low. So again, as a reminder, the approach there is to hit that 5 to 10 pounds of N per week, divide that into multiple applications, bearing in mind the percentage of nitrogen in your product and what your area is that you're applying. Okay, starting to run out of time. So let's wind this down. Final thoughts here. I said I was using tomatoes as a lens, and I did that, but I want to acknowledge that there are a number of people that approach the calendar year for their greenhouse or high tunnel, and they might break it into a tomato crop and a greens crop. So now how do we factor in the fertility for that second crop, whatever it is? It could be cucumbers, it could be a spinach, it could be many things. What we have found in the colder months is that since the crop is growing slower, it's easier for us to stay within nitrogen sufficiency ranges. So this is research we did a few years back, looking at percent nitrogen, in this case, in a spinach crop, using multiple sources of nitrogen, all at the same rate. So we're looking at urea, control is no nitrogen, blood meal, and alfalfa meal. And the interesting thing is that we stayed within our sufficiency range of between 3 and 5.5% nitrogen throughout the entire winter, really regardless of our nitrogen source in this case. So what I'm suggesting here is that if you're growing 2 crops, that crop in the second season is probably going to run on the leftover nitrogen that you have from your summer crop, or it simply doesn't need as much because the soil is colder and the crop is growing slower. So we want to bring in our science from hydroponics, but factor in the fact that our soils provide us with a bank of nutrients that hydroponics doesn't. And if we're not mindful of that in pursuit of nitrogen, we'll over apply other nutrients. For our split applications, we want to look at maybe 50% pre-apply, and then whether you're conventional or organic in your in-season approach, let's break those applications into weekly doses that are further broken down into 3 to 4 applications alternated with clear water. And the value of testing can't be overstated here. Test in season to make sure that your approach is working, and Talia and Perennia are a great resource to help you with that testing, as well as developing your overall nitrogen management approach. I'm going to stop here, and I hope there aren't too many questions, because I can only do that math once or twice a day.
Well, we might be pushing that a little bit. We've got a few questions in the chat here.
Yes.
We'll start you off easy, though. So there is a little bit of debate when it comes to the proper soil test to use in a greenhouse soil. So typically we see people submitting either using a standard soil test that you would use for field soil, or you'll see people submitting greenhouse soils under a saturated media extract. So kind of a two-parter here. So one is the results that you shared sort of early on in your presentation. Was that done through saturated media extract or a typical soil test? And part two, do you recommend one over the other?
Yeah, so everything I share is from a traditional mineral extraction. The one specifically that we use here is called a modified Morgan's, which there's further debates about what's the best way to extract nutrients. So I just use traditional extractions, and that is my preference, because I don't think saturated media extracts are fully revealing to us the contribution of the mineral fraction. So just so everyone knows, saturated media extract, as Talia knows, is a greenhouse extraction, and it's based on potting media and not mineral soil. So even though we might have some of our soils hit that 20% organic matter mark, that means that 80% of that is still mineral. And so I would want to account for that. It's a discussion I'm open to having, but that's where I am with it right now.
And I think it's an appropriate distinction to make, because I think the language on some of these lab tests or these lab testing services can be confusing, where you are growing in a greenhouse but are soil based. We want
Correct.
to follow the route for a soil test, despite the fact that the word greenhouse is written in there. So for anybody who is unsure of what test they want to use, definitely reach out and we can make sure that you're doing the right one. Okay, next question. So would limestone help with bringing salt levels down? And then the part two to that is then how can we drive the EC down to a manageable level?
Sure. And I'm moving through these questions quickly just because I went a little long, but so don't think my answers are comprehensive. Limestone is not going to adjust your salt, your EC level. Some people have shown that an application of gypsum with followed by heavy irrigation can reduce sodium levels. Now, what we have to bear in mind is that not all salts are sodium. Magnesium chloride is another salt. And so in that case, you're not going to reduce your total salts. And the second part of that, I think, Talia, was just reducing EC overall. Probably the best way to do that is to run water through the soil profile, either through intentionally flooding the soil if you can, or I think better yet, removing the plastic every few years if you can, and allowing a full season of rain and snow to move through it.
Yeah, absolutely. Okay, the next question. So is the OMAFRA / Knott's handbook the sufficiency range that you would suggest?
Yeah, I think I'd have to go back and look at it, but it might, that's a great question. It's because it's a little challenging. So let me look at it real quick. I don't think so. Yeah, so it's not, because their K level, so their potassium level is actually lower than what I would like to see. That they go with they're in the, well, no, they're between 2 and 4. I think 2 is low. So the real quick answer there is I would rather see the potassium level no lower than 3.5%.
Yeah.
I don't agree with it 100%, but I mean, who knows more, Knott's handbook for vegetables or me? So you certainly can't go wrong going with Knott's.
Yeah, I mean, I think it's a difficult thing that we've all sort of run into, where we see a lot of different sources. We see a lot of different recommended levels of nutrients depending on what institution is publishing these. I guess, do you have any words of wisdom?
Well, it's a big question. So in our own work, we actually looked at, like, say, the top 3 or 4 sets of sufficiency ranges and had a process where we chose which ones we were going to go with. They're not hugely off. Let's bear that in mind. None of them are off by a lot, but they might be off by a point or two. The other thing is, those are just numbers on a page. And in the end, what is sufficiency for a specific grower is going to be very different. Are they growing an heirloom type of tomato? Is the thing 3 meters tall, or is it 1 meter tall? Does it have a very heavy fruit load, or does it have a low fruit load? So again, those are just numbers on a piece of paper to guide us.
Absolutely. And I think, you know, as you had sort of mentioned at the beginning of your presentation, keeping up with those tissue tests throughout the season are going to kind of help tell you how you're doing, if you need to bump that up, if you maybe need to knock that down. So it's sort of there's a lot of pieces that kind of come together to decide what that value should be. Okay, next question. So when you're calculating your greenhouse size, are you calculating the total greenhouse area or just the beds themselves?
Another great question. I do the total square area. I do. I know there's some people that would suggest you could drop the rows out from that. I find the crop responds as if I'm treating the entire acre, so entire area. So I use the whole area.
Great. With regards to slow release fertilizers, do they break down at different rates depending on soil temp, or do you find that they're available at a relatively constant rate?
The quick answer is yes. They break down at widely variable rates depending on temperature and biology. And so this is one of the dangers of the very high organic matter approach, is that you're actually creating a large background bank of nitrogen. And what I've seen happen is, in the middle of summer, when your temperatures peak and humidity is high, your soil moisture is high, there's a flush of microbial activity, which leads to a real pulse of nitrogen at a time where you may not want that. And you can see real high levels. So that's why we try to avoid those extremes. One reason to avoid those high organic matter levels.
Yeah, absolutely. Do you know of any alternatives to Agmino for organic growers? It doesn't look like we can get Agmino in Canada at the moment.
I don't. I would waste time if I tried to do that. I would kick that to Talia, and I think Talia can probably lead people directly to good vendors in the area.
And kind of, I guess, a part two to that, you mentioned that you weren't necessarily a fan of blood meal, or you would kind of trend away from that. Was it
just for salts? That's my only reason, is just for salts. Yeah.
Okay.
Yeah.
Yep.
And occasionally I have worked with some farmers that want an entirely plant-based system for their own set of values. And I think that's another reason. But I do like blood meal as an in-season amendment. It's not soluble. That's one of my other major objections to it.
Okay, great. Last question here. One of the last questions. Sorry, we'll try not to ramble on too much longer. What would you recommend as sort of an ideal level of organic matter?
That's another great question. I appreciate your perspective on that as well. But I think organic matter, there's not one value you need to get to, because again, a sandy soil, it's hard to maintain a high organic matter. In that case, a sandier soil, I think a target of 3 to 4% is actually probably pretty good. Maybe that's about as good as you're going to do. With higher clay, silt, or loam fractions of that soil, you could push that up into 6, 7, 8. A lot of people probably wouldn't like me saying this, but I don't believe there's a lot of value in going over 10% organic matter in your soil. That's just my own experience. But
yep. No,
yeah.
I appreciate that. And I think I'm gonna ask just one more question here, and you kind of touched on it. Where you're providing a lot of water to the crop and you're supplementing that nitrogen, and like you said, after a certain point, you're kind of just funneling it down almost away from the crop. How would you sort of manage your fertigation schedule, I guess, in relation to that irrigation schedule? Like, do you find there's a time of day that's maybe the best time to apply, or?
Yeah, that's a great question. I haven't examined it myself. What I've seen other people show is that probably the best time to apply is immediately prior to peak demand. So that puts you somewhere around 10 in the morning, 10 a.m. In our part of the world. Yeah. Now the question is, if you know that you've got to run, in a sense, you have to leach water to meet the crop demand or keep it from wilting or having water stress, do you put that nitrogen early or late in that cycle? That's a good question. I'm open for discussion on that. Whatever I can do to maximize plant uptake, I would guess it would probably be earlier in the cycle.
That would kind of be my assumption too. Yeah. I mean, the peak part of the day, the plant is really just trying to kind of cool itself down, right?
Yes. Yeah.
So really, I think, if you aim for that 10 a.m. for your nitrogen application, that's right kind of before that heat of the day really, really, really starts to set in. So I think that is a great suggestion. I think that correlates well.
Yeah, that sounds good to me.
Cool. All right. Well, thank you everybody so much for attending. Thank you for your questions and discussions. I'm just going to toss up a few QR codes here. Okay, so we have a couple QR codes. One of which is to the off-calf upcoming events. The other is to Perennia upcoming events. I posted a link to the post-workshop survey in the chat if you guys want to take a few minutes just to fill that out. Your feedback is highly appreciated, just so that we can help guide future sessions and make sure that we're answering those questions that you do have. I also want to put a bit of a plug in for our awesome upcoming in-person tailgate meetings. So Judson will actually be coming to Nova Scotia, and we're going to spend that first week of July visiting on farm and basically just having discussions about cover crops, nutrient management, and all that good stuff. So thank you so much, Judson, for your time, and feel free to reach out if you have any questions post-session.
Thanks to you, Talia, and thanks to Perennia.
Have a good day, guys. Bye.